Good morning, everyone. Good morning to our instructor, Forester Hannah G. Pantaleon. Today I will discuss forest soil and climate change. Forests play multiple and vital roles in climate change. They are great reservoir of stabilized carbon, and their carbon sequestration potential can considerably be improved by appropriate management. They have the potential to absorb about one-tenth of global emissions. Project for the first half of the century in their biomass, soils, and products and stored them. They react sensitively to a changing climate, and when managed sustainably, they produce wood fuels as a benign alternative to fossil fuels, and they currently contribute about one-sixth of global carbon emissions when cleared, overused, or degraded. Forest soils constitute a large stock of carbon. The schematic diagram showing the carbon emission process. The emission from forest soils. Healthy forests are the most efficient, inexpensive, and natural system to combat climate change. At the global level, 19% of the carbon in the Earth's biosphere is stored in plants, and 81% in the soil. In all forests, tropical, temperate, and boreal together, approximately 31% of the carbon is stored in the biomass and 69% in the soil. An estimate shows that global forest vegetation stores 283 gt of carbon in its biomass, 38 gt in dead wood, and 317 gt in soils, top 30 cm and later. The total carbon content of forest ecosystem has been estimated at 638 gt for 2005, which is more than the amount of carbon in the entire atmosphere. According to the Millennium Ecosystem Assessment, drylands occupy 41% of the Earth's land area and are home to more than 2 billion people. Intensive human intervention, for example, fire, grazing, agriculture, and firewood collection has adversely transformed many dry forests. According to the Intergovernmental Panel on Climate Change, the conservation and restoration of forests can considerably reduce emissions. Clearing and burning of peat swamp forests in Southeast Asia could contribute to 3% of total global human emissions. According to scientific estimates, forest fires in Indonesia in 1998 burned some 8 million hectares of land and released between 0.48 and 2.57 gt of CO2 into the atmosphere, which is between 13 and 40% of the mean annual global carbon emissions from fossil fuels. Climate change affects the ecosystem productivity and allocation of above versus below biomass. Carbon emissions from deforestation and forest degradation have been estimated to account for about 20% of global anthropogenic CO2 emissions, suggested that carbon emissions from both deforestation and fossil fuel combustion in 2008 should be around 12%, reported that deforestation contributes 6 to 17% of global anthropogenic carbon dioxide emissions to the atmosphere. Deforestation is the long-term reduction of tree canopy cover to below 10 to 30%. The albedo effect is another concern of boreal deforestation. When boreal forests are cleared, there is a change in the albedo due to the changed color of canopy. Clearing tropical forest could release an additional 87 to 130 GTC as CO2 to the atmosphere by 2100. The magnitude of emissions depend on the rates of deforestation, the biomass of the forest deforested, and other reduction in biomass that result from forest use. Afforestation and reforestation of degraded land may enhance soil sea stack. Global temperature are apprehended to increase by 1.1 to 6.4 Celsius during the 21st century. As soils are intricately linked to the atmospheric climate system through the carbon, nitrogen, and hydrologic cycles, altered climate change will also affect soil processes and properties. And at the same time, the soils themselves will have an effect on climate. The environmental constraints that can temporarily or indefinitely affect apparent temperature sensitivities of decomposition include the following. Number 1. Physical protection of organic matter against decomposition by binding humus particles to the interior of aggregates, where microorganisms and their enzymes may have limited access, or by low water solubility or occurrence of enzymes in hydrophobic domains of humified organic matter. Clay content exerts a powerful control on the size of the older soil carbon pool in Amazonian soils. Number 2. Chemical protection of organic matter by absorbing in mineral surfaces through covalent or electrostatical bonds. Number 3. Drought, which reduces the thickness of soil water films, thus inhibiting the diffusion of extracellular enzymes and soluble organic C substrates and lowering substrate availability at reaction microsites. Then number 4. Flooding, which slows oxygen diffusion to decomposition reaction sites, often allowing only anaerobic decomposition, which includes fewer and generally slower degradative enzymatic pathways. The importance of anoxic conditions for the preservation of organic matter in boreal peatlands is without doubt. Number 5. Freezing, for which the diffusion of substrates and extracellular enzymes within the soil is extremely slow where the extracellular soil water is frozen. Thank you for listening.